yesterday I have given the idea regarding the true shape. Now we can see that in order to get the true shape of the section, remove the portion in between the cutting plane and the observer. If you are looking from the top, remove the portion in between the cutting plane and the observer. So you can see that this will be your sectional front view, sorry, top view. The top view will be, sectional top view will be a triangle. So what you are getting is the same base triangle as sectional top view. But this is not the true shape of the section. In order to get the true shape of the section, you should look perpendicular to the cut surface. Now you can see the size of this triangle is not equal to the base triangle. Here the true shape is larger than that of the base triangle. So in order to get the true shape of the section surface, you have to draw a line parallel to the cutting plane at any convenient distance from the cutting plane. Mark it as say x dash, y dash. Now draw perpendicular lines from 1 dash to 2 dash and to 3 dash. Okay, all these lines are 90 degree to the new reference line. Now in order to get the true shape of the point 1, what you have to do is apply the trapezoidal method. That is, take the distance of 1 from the xy line, mark it here, so you will be getting, take the distance of 1 from the xy line, we will be getting the top view of the, true shape of the point 1. Then 2 is at this much distance from the xy line, take that distance, cut it here, you will be getting 2. 3 is also equal to the same distance of 1, so I can mark. So this is the point 3. Now we join 1, 2, 3 and okay, this is the true shape of the section. This is the true shape. And true shape is also represented with hatched lines. This hatched lines will be at an angle of 45 degree to the nearest reference line. In this case, this is your reference line, so the angle should be 45 degree to this reference line. Okay, so this is the way in which you'll be getting the sectional front view, sectional top view, and true shape of the cut solid. In the same case, we'll take the position of the triangle, base triangle like this. Now let us observe what are the changes taking place. Okay. So after drawing the plan and elevation, I will be drawing the cutting plane as usual. Okay. The third step is identify the cutting points. So here the cutting point here is cutting only one edge, A dash, B dash. So I will be marking 1 here. But when you come to this side, it is cutting the lines B dash, Q dash and C dash, R dash. So imagine or assuming cutting the line B dash, Q dash at 2 and C dash, R dash at 3. Here also you can see that the number of cutting points is equal to the number of longer edges. Here, the earlier case, there is only one edge, So I will be marking only 1. Here there are 2 edges, 2 dash, B dash, 2 dash at 2 dash, and C dash, R dash at 3 dash. Now in order to get the true shape, draw a line parallel to the cutting plane, project all the points perpendicular to this. Okay. Take the distance of and plan of the point. B will be 2 will be here, then 3 will be here, 1 will be here. Okay. Take the distance of 3 from the xy line, mark it here. Take the distance of 1, mark it along this line, 3 and get join 1, 2, 3. Say hatch the surface, you will be getting the true shape. So the one thing I remember is number of cutting points is equal to the number of longer edges. If it's if you are cutting a square prism, number of cutting edges will be equal to 4 because you have to cut all the 4 longer edges in order to cut the solid fully. Thank you.